Welcome back to the deep dive. This is where we take the sources, discard all the noise, and really deliver the actionable, distilled insights you need to be seriously well-informed. Today, we are venturing into a discipline that, on the surface, sounds purely technical site reliability engineering, SRE.
Right. It sounds like it's all about servers and code.
Exactly. But it's actually, at its core, a system of human governance. We're going to be talking about the established social and even economic architecture that keeps the world's most massive technology platforms running.
And more importantly, how humans behave when those systems inevitably fail. Because they will.
They always do. So we're not just looking at code today. We are diving deep into the rules of, conflict resolution, accountability, and resource management within these really high-stakes engineering environments.
We're calling it the rules of engagement.
That's it, the rules of engagement.
And for you listening in, let's be really explicit about the scope here. This discussion is going to cover strictly the SRE and incident management domain.
Right. We're not going to wander off into, CI/CD pipelines or other areas.
No, not today. We are laser-focused on the essential concepts, the frameworks, the philosophies, and the documented rules that govern how these high-performance technical teams manage chaos.
And how they assign tasks, and this is critical, how they balance the need for reliability against that relentless pressure to ship new features, to go faster.
It's a need for speed.
Our mission really is to take these cultural contracts and the hard economic realities of modern software operations and just transform them into knowledge that sticks.
We want you to walk away understanding not just, say, what an SLO is, but why the whole system works as a machine for continuous improvement.
Ultimately, the core narrative here is about those rules of engagement.
It is. How do companies make sure that when systems break, and let's just be honest, they always do, that the human response is constructive, fast, and focused on building future resilience?
Instead of just, descending into finger pointing and paralysis.
Exactly. That's the challenge. And SRE provides the governance model to solve that exact problem.
Okay, let's unpack this. Where do we start? I think we have to start with what is arguably the most radical cultural shift SRE demands.
It has to be blamelessness.
Blamelessness. This is the foundation. It's the golden rule of incident response. And the rule states, when an incident occurs, we're looking for the process failure, not the person failure.
And that shift it's profound. I mean, in traditional organizations, especially ones rooted in older IT ops models, the immediate reflex is to conduct a kind of witch hunt.
Oh, absolutely. Who clicked the button?
Who wrote the buggy code? Who approved the release? But in today's complex distributed systems, you're running across multiple clouds, microservices, dozens of teams. That single point of failure, it rarely exists.
It's a myth.
It's a total myth. The failure is almost always systemic.
We saw the perfect illustration of this in the source material, a scenario involving a really critical production-level incident. A new software release was deployed.
The classic scenario.
Right. And it almost instantly exhausted the available service memory resources. That required an emergency rollback, a potentially very, very costly procedure to mitigate the impact on users.
And in that moment, the natural human response is, first, fear, and that's immediately followed by the search for the individual who pushed the release that caused the memory leak.
You want a name.
You want a name. But the SRE approach, it just flips the script entirely. The practice requires concentrating on identifying the contributing causes, and that's plural of the incident.
So not just one thing.
Never just one thing. We look at why the load testing missed the memory leak. We look at why the resource limits were configured too tightly. We ask why the deployment pipeline allowed this specific change to get through in the first place.
And why didn't the monitoring system alert before the memory was fully exhausted?
All of those things. We're explicitly not looking for the engineer responsible for the immediate push.
But I have to push back on this a little bit because this is where, the organizational friction happens. If we say it's always the process, never the person, doesn't that inherently lead to a lack of accountability?
That is the most common critique.
How do you maintain discipline if everyone knows they can't be fired for an honest mistake?
It's a great question, and it's a really important distinction to draw. Blamelessness is not the same as unaccountability. They're two different things.
Okay.
Blamelessness simply acknowledges that high-performing professionals, people who care about their jobs, do not intentionally cause outages. When they make an error, they do so within a system that permitted the error to happen.
So the system failed.
The system failed them. Our goal is to fix the system, not punish the person.
So where does the accountability come in?
Accountability in SRE is applied forward-looking.
Mm-hmm.
It's about being accountable for the fix, which we'll get to when we talk about action items. But
Mm-hmm.
think about it this way. If engineers fear punitive action, if they know their mistake is going to result in a formal reprimand or even losing their job, what do?
They hide it.
They will universally hide mistakes. They'll hesitate to report incidents quickly. They'll minimize the details in the aftermath.
That's a huge point. If the system is designed to punish failure, engineers are incentivized to conceal failure, and that means the organization never learns from it.
And concealment is fatal to reliability.
It's the worst possible outcome.
Exactly.
Hmm.
Blamelessness is an engineering necessity because it promotes radical honesty, it promotes rapid reporting, and it promotes complete data capture. It's really the only way to get the full, unvarnished story you need to prevent it from happening again.
And this commitment to learning leads us directly to the sort of official mechanism for institutionalizing failure, the postmortem.
Yes, the postmortem. They are mandatory,
Yeah.
and they serve this profound cultural role of institutionalizing learning. I love the analogy of a postmortem being like a black box flight recorder investigation.
Oh, that's a good one.
Right. When the NTSB investigates a plane crash, they don't start by asking which pilot to fire. They recover the recorder, they study the telemetry, they interview everyone involved, and the sole objective is systems-level improvement.
The goal is safer skies, a more resilient system for everyone globally, not firing the pilot.
Exactly.
So given the weight and importance of this document, what constitutes a truly good postmortem according to the SRE rules of engagement we saw in the sources?
A good postmortem, it has to be comprehensive, factual, and strictly focused on prevention. The sources are very, very clear on the non-negotiable requirements.
Okay, what are they?
First, the content must include a detailed explanation of what caused the incident, the technical root cause, the sequence of events, all the contributing factors.
So it's not enough to just say the deployment caused the server crash?
No, that's useless. You have to explain why that specific code change was deployed without sufficient testing, why the metrics weren't being watched closely enough, and what specific engineering level changes will be made to the pipeline to prevent it.
So it's a deep technical dive.
Absolutely. The technical depth has to be sufficient for a peer engineer to fully understand the vulnerability. But that's only part one.
Okay.
Second, and this is just as important, it must include a list of concrete, measurable action items to prevent a future recurrence. Without those preventative steps, it's just history. It's not learning.
It's just a story.
It's just a story. But the postmortem also serves a powerful cultural function beyond just the technical content. It must ensure that all incident participants are involved in the postmortem authoring process.
That's fascinating. Why is that so essential? Why does it matter who writes it?
Well, it achieves several things at once. First, it ensures the perspective is accurate. You're capturing the chaos and the reality experienced in the trenches, not just some clean, theoretical view from management.
Right, from someone who wasn't there.
Exactly. It also combats that perception of being investigated because the people who are involved are the ones defining the historical record and identifying the fixes themselves. It gives them agency.
It makes it more authentic.
More authentic, more relatable for those reading it later. And the final crucial cultural rule is that this institutional knowledge, it must be shared as widely as possible throughout the organization.
So this isn't some secret document for the SRE team.
Not at all. It's a mechanism for cross-pollination. Other development teams might learn about shared vulnerabilities in a common library or identify dangerous assumptions they didn't even know they were making. Wide sharing is a critical element of knowledge transfer.
And for all of this effort to be worthwhile, the organization has to actively support it. I mean, if writing a postmortem feels like homework, engineers are just going to rush through it and the quality will suffer.
And this is where senior leadership modeling becomes essential. Leadership has to be encouraged to acknowledge and participate in postmortems.
So not to assign blame.
No, not to assign blame, but to attend the review sessions, ask constructive questions about process improvements, and visibly support the blameless framework.
It has to be seen as a valuable contribution.
It has to be a rewarded practice. Maybe it gets factored into performance reviews. It has to be seen as a valuable contribution to resilience, not just an administrative chore. If it's celebrated, the quality stays high and the learning compounds over time.
So given that level of commitment, you can't do this for every tiny blip. Not every hiccup can trigger this massive investment of time and energy.
No, you'd be writing postmortems all day.
Right. So what are the defined non-negotiable thresholds that force this social contract, the full postmortem investigation, to kick in?
The sources define very clear boundaries to prevent, alert fatigue and investigation sprawl.
Ah,
A postmortem is required when certain critical thresholds are crossed that signal a severe impact to the customer or
mhm.
to business trust.
Okay, like what?
The first major trigger is when data is lost due to an incident. Data loss, regardless of the severity of the downtime, is a major, major failure, and it necessitates a full investigation to secure user trust and often regulatory compliance.
That makes sense. What's the other one?
The second key trigger is when an external stakeholder asks for one.
Ah,
This usually means a key customer, maybe a regulatory body, or perhaps a senior business leader whose trust has been significantly shaken.
so that second point, that immediately connects the technical reliability directly to the business perception. An external request signals high severity and high visibility.
Exactly. It makes the investigation mandatory simply due to the business context, even if the data loss wasn't massive or the downtime was short. If the incident generated significant customer-facing friction, the requirement for a public, documented explanation, the postmortem becomes paramount.
And the loop has to close.
The loop has to close. To maintain that learning, every postmortem triggered must include a full root cause explanation and, again, that list of specific action items to prevent recurrence. No fix, no value.
Okay, that brings us to the next big piece. We've navigated the chaos, we stabilized the systems, and we've written this brilliant, blameless postmortem cataloging every systemic failure. Now we have a list. Maybe 20 highly detailed action items that, once implemented, will make the system exponentially safer.
And this is the pivot point.
This is it. Moving from that high-level, blameless culture to the practical reality of execution.
And this transition is where so many organizations fail. Blamelessness applies to finding the cause, right? It promotes transparency, but the action item economy applies to fixing the cause, and that demands accountability.
You can have the best postmortem in the world.
But if the fixes are never implemented, the entire exercise was a waste of time, a total failure. General goodwill and, shared responsibility, there's simply not enough to drive critical fixes.
Especially when product teams are incentivized to prioritize new feature coding, that's what gets them promoted.
Exactly.
This is exactly where we introduce the analogy I find most useful. Let's talk about the potluck dinner.
Yes.
If you send a group email to 20 people saying, hey, we're having a potluck, someone bring salad, what's the result?
You might get no salad. Or if you have a group of very over-anxious people, you get 8 bowls of Caesar salad and nothing else.
Exactly. The danger is the diffusion of responsibility. Everyone assumes someone else is handling the critical task, and in this case, the vulnerability just sits unaddressed in the backlog forever.
And the same principle applies directly to action items. If we assign a critical security patch to the infrastructure team or the platform SREs,
It's just an orphan task in a shared ticket queue. It's potluck salad.
it is. And that's precisely why SRE developed the rule of the action item economy. It's the system designed to enforce that forward-looking accountability without assigning historical blame.
And what's the rule?
The rule is explicit. It's detailed right there in the source material. For action items generated during a postmortem, you must assign one owner for each action item and then any necessary collaborator.
One owner, single ownership. That's the critical factor.
It's completely non-negotiable. If everyone owns it, no one owns it. The single owner is responsible for ensuring the task is properly scoped, prioritized with the relevant product teams, completed quickly, and then thoroughly tested to verify it actually addresses the root cause identified in the postmortem.
Collaborators can help.
Collaborators can assist, but the buck stops with that singular named individual. This is how the organization translates that blameless learning into accountable, measurable execution.
That provides the accountability structure for the aftermath of the incident. Now, let's pivot and address the moment of crisis itself. Before we're assigning action items or writing postmortems, the team has to stop the bleeding.
Right.
What are the immediate rules of engagement during that initial triage and response?
The immediate rules prioritize mitigation above all else. The number one objective is to minimize user impact as swiftly as possible. This means prioritizing fast action over deep, precise root cause analysis.
So you fix the symptoms for the user first.
You fix the symptoms first, then you diagnose the underlying disease later in the calm of the postmortem.
Let's use the scenario from the sources. A highly popular mobile game application, it relies on a container platform like GKE across multiple cloud regions, and suddenly it loses connectivity for all users in one specific geographic region.
So a partial outage, but it's 100% failure for a segment of your users.
Exactly.
The first mandated SRE practice in that high-pressure scenario is not to start digging through logs in the affected region. It is to focus purely on user experience by rerouting the user traffic from the affected region to other regions that are confirmed to be healthy.
That seems logical, but I mean, that's a high-risk move in itself. You are immediately dumping a ton of load onto systems that were not expecting it.
It is a calculated risk that prioritizes immediate recovery. Rerouting traffic is almost always the fastest way to get users back online. And yes, it might mean temporarily stressing the healthy regions.
Or users might see slightly worse performance.
Right. They might experience slightly degraded performance due to cross-region latency, but it's vastly better than 100% outage for that segment. Mitigation first, always.
And this principle of deliberate, stability-focused action, it extends to even the most granular, expert-level incident management, right? Like handling a single failing node within a service fleet.
Oh, absolutely. Imagine you're monitoring a core API service. The fleet is running comfortably, but one specific node starts returning a high volume of 5-ox errors, serious internal server errors.
And customer support is lighting up.
Exactly. They're seeing a spike in failures. Your job is to remove that bad actor immediately.
My gut reaction, especially under that kind of stress, would be to just terminate the failing node, just kill it instantly to stop the bad responses. Why would that violate the SRE rules of engagement?
Because that hasty action can cause a cascading failure across the entire service. It can turn a partial outage into a total one.
How?
If you immediately kill the node, the load balancer instantly redistributes all of that node's traffic to the remaining healthy nodes. If those healthy nodes were already running close to their maximum save capacity.
That sudden load increase could push them over the edge.
It could push them over the edge, causing them to start failing too, or trigger resource exhaustion across the whole cluster.
So you turn a single localized failure into a systemic meltdown.
Exactly. So the recommended practice is a carefully controlled, multi-step process that prioritizes stability over raw speed. First, you must communicate your intent to the incident team. Never operate in a vacuum. Everyone needs to know you're about to remove a node.
Okay, step 1, communicate.
Step 2, and this is a critical safety check that requires hard data. You must perform a load analysis to determine if the remaining nodes can handle the increased traffic that will be offloaded.
You have to do the math?
You have to do the math. You analyze current CPU usage, memory pressure, request queue depth across the rest of the fleet.
So if the math shows that the remaining nodes are already near, say, 90% capacity, you can't proceed. You have to scale up first.
You must scale first.
Yeah.
You trigger the autoscaler, or you manually provision additional capacity if necessary, and you wait. You wait until those newly provisioned nodes are reported healthy and are ready to accept traffic.
Only then do you move forward.
Only then, when you have confirmed capacity and you've communicated the action, do you proceed to the next step. You drain traffic gracefully from the unhealthy node, and finally, you remove the unhealthy node from service.
That sequence, it just highlights that even in a crisis, SRE favors measured, calculated action guided by real-time data rather than just reactionary fixes.
Haste is the enemy of stability.
It seems like it.
It's operational foresight. It takes slightly longer, maybe an extra minute or two, but it guarantees that the mitigation action itself does not create a bigger, more disruptive incident. And that is the essence of responsible, expert-level incident response.
Okay. We've established the social rules, blameless learning, and the operational rules, accountable action, safe triage. Now let's pivot to the final and perhaps most disruptive rule of them all, the economic contract.
Ah, yes, the error budget. This is what truly defines SRE as a business-driven function. It separates it from traditional operations teams that often chase the impossible and incredibly expensive goal of 100% uptime at all costs.
It's a different way of thinking.
It is. SRE recognizes that reliability is not some moral imperative. It is a finite resource that has to be budgeted and managed, just like currency.
Let's make this simple. Let's use the bank account analogy.
Perfect. So when you define an SRE system, you set a service level objective, an SLO. If your SLO is 99.9% availability, you are contractually allowing for 0.1% downtime or failure over a defined period, like a month.
Right.
That 0.1% tolerance for failure, the allowable deviation from perfection, is your error budget. It's literally the money in your reliability bank account that you are allowed to spend.
And the real power of the budget is that it explicitly gives engineering teams permission to fail occasionally,
Yes.
provided they stay within that defined threshold.
Exactly. The budget isn't just a punishment metric, it's reliability capital. If you haven't used your budget, it means your system is inherently stable and efficient, and you therefore have capital that you can spend on faster, riskier, high-velocity projects.
You can move fast because the system has capacity to absorb risk.
You have money in the bank. But conversely, if the system is constantly unstable, you are rapidly running out of money, and the economic contract comes due.
The consequences are immediate.
They're immediate and they're business mandated. Let's look at the scenario from the sources. A specific service has exceeded the error budget for the current rolling window. They've already used up their 0.1% failure allowance.
They're bankrupt.
They are bankrupt. And at the same time, the product team is aggressively planning to launch a risky new feature, maybe a major infrastructure change.
This is the exact moment where SRE steps out of the infrastructure world and becomes like the chief financial officer of the product's stability.
That's a great way to put it. The mandated practice is stark and it's contractual. The SRE team must immediately notify the product team that their error budget is used up.
The bank is closed.
The bank is closed. And then they must negotiate for a launch freeze or, at a minimum, demand that the team tolerates a significantly worse user experience if they insist on proceeding.
A launch freeze is a serious power. I mean, that means SRE can essentially stop the entire product development velocity for a period of time.
It's the ultimate check and balance. If the service is unstable and the organization keeps pushing risky changes, the result is catastrophic failure and violation of the customer contract, the SLO.
So you have to stop the bleeding.
By implementing a mandatory freeze when the budget is spent, SRE forces the product team to shift its priorities entirely. They have to move from feature development to reliability work.
Paying down the debt.
Specifically, paying down the operational debt that consumed the budget in the first place.
And crucially, the rules prevent any kind of, financial trickery. You can't just cook the books.
Correct. The sources emphasize that you can't simply request additional budget. You can't try to reallocate budget from other unrelated SLOs. That budget is fixed. It's fixed by the technical requirements and the customer-facing contract.
Right. If the customer expects 99.9% uptime,
you can't suddenly decide that 99.0% is fine and give yourself more money to play with. The budget dictates feature velocity, and that budget is defined by technical reality. This whole framework forces a data-driven negotiation between velocity and stability.
And this entire system exists because SRE is not about achieving perfect reliability. It's about maximizing business value.
Perfect uptime is often prohibitively expensive.
And just unnecessary for the business needs.
And this is where we need to put on our sort of accountant hat and really dig into the economic calculation scenario that was provided. This scenario perfectly illustrates why SRE decisions are business decisions, not just engineering ideals.
Okay, let's set it up. An organization runs a critical application. It's generating $1 million in current annual revenue. The application currently operates at 99.9% availability. We call that 3 nines.
Very common target.
Right. And an engineering proposal is put forward to increase the availability target to 99.99% 4 nines. The investment required to implement the necessary redundancy, tooling, and architectural changes for this higher availability is budgeted at $2,000.
So we have to answer the purely economic question. Is spending $2,000 to move from 3 nines to 4 nines actually worth it for the business? We need to quantify the value of that extra reliability.
Let's walk through the math slowly so everyone can follow the logic. At 99.9% availability, the service is allowed 0.1% downtime.
Correct. And at the proposed 99.99% availability, the service is allowed only 0.01% downtime.
So the difference is what we're buying.
Exactly. The incremental gain in availability that the $2,000 investment is buying is the difference between those two downtime allowances. So 0.1% minus 0.01%, which yields a 0.09% difference in maximum allowable uptime.
And that 0.09% represents the potential revenue saved from that avoided downtime. So we apply that percentage to the application's total annual revenue.
You got it. When you take 0.09% of the $1 million application revenue, the calculation determines the value of improved availability to be precisely $900.
$900.
That is the projected financial benefit of moving to 4 nines.
And the conclusion is inescapable and completely business-driven. The value of the improved reliability, $900, is less than the investment cost of $2,000.
which means the increase in availability is not worth the investment, at least for a single year of usage.
This is the SRE economic contract in its purest form. We don't strive for 4 nines just because it looks better on a marketing slide.
We only strive for it if the calculated financial return, the value of the extra reliability, exceeds the cost of delivering that reliability. SRE forces the organization to optimize that balance. It ensures resources aren't wasted, chasing degrees of perfection that the business doesn't actually need or, frankly, pay for.
It's a constant argument against over-engineering.
It is. And this framework instantly connects that engineering decision directly to the organization's bottom line. That's why the error budget is such a powerful diplomacy tool in the relationship between SRE and product development. It's a contractual negotiation, and it's backed by hard numbers.
Okay, so we've covered the entire life cycle. We learned from failure, we assigned accountability for the fixes, and we paid the economic price. Now, how does SRE ensure the long-term health of the entire ecosystem? I'm talking about both the systems and the human engineers who operate them.
This brings us to the continuous, and I mean continuous, effort to reduce toil.
Define toil for us.
Toil is a fundamental concept in SRE because it is the absolute antithesis of value-added work. We define toil as manual, repetitive, tactical, and operational work that scales linearly with service growth.
So as the service gets bigger, the toil gets bigger.
It gets proportionally bigger. It's the necessary but ultimately mind-numbing work you have to do just to keep the lights on. Things like manual cluster restarts, clicking through administrative consoles, or running the same deployment commands over and over.
It is the enemy of strategic thought and innovation.
Precisely. So to ensure the system and the engineers remain healthy and focused, SRE mandates the need to identify, measure, and eliminate toil by automating repetitive tasks. The rule requires that SREs spend a certain percentage of their time, often it's 50% on engineering projects, which includes automation.
The goal is to free up their brain power.
The goal is to free up engineering resources to focus on high-value tasks. New feature work, technical debt reduction, and ironically, more automation that reduces future toil. If you don't fight toil actively, it will consume your entire engineering team.
And related to that is alerting burnout. I mean, if the automation is so good that the system can fix itself, let's say a temporary network blip causes a minor outage that self-heals in 60 seconds.
Right.
But an engineer is still paged at 3 a.m. to acknowledge that incident, that is pure human toil.
And it's destructive.
Yeah.
The SRE solution for this high-volume, self-healing outage scenario is absolutely essential for staff retention and mental health, eliminating alerts that are not actionable to prevent staff burnout.
The cry wolf syndrome.
It's exactly what it is. If engineers are constantly woken up for things they cannot or should not manually intervene in, they quickly become desensitized. They start ignoring the noise.
And then the big one comes.
And when a truly critical, non-self-healing incident occurs, they are slower to respond because they've learned that most pages are pointless. An alert must require a human response that adds measurable value. If the system already fixed it, the alert should go to a log file, not to a pager.
That focus on protecting the engineers seems like a core part of maintaining system health. Now, let's shift to proactive preparedness. We've talked about fixing things after they break, but how do SRE teams use data to look ahead and guarantee reliability?
Now we move into the realm of capacity planning, which is all about anticipating the future load. Before any major predictable event like a massive holiday shopping season for an e-commerce application, which we saw detailed in the sources, you just can't rely on hoping the systems will handle the traffic spike.
Hope is not a strategy.
Hope is not a strategy. So if we know a massive spike is coming, what is the absolute first step for preparedness?
I would guess it's gathering data.
That's it. The very first step is to load test the application to profile its performance for scaling. This is empirical data gathering. You need to know exactly where the bottlenecks are, how the current architecture handles traffic beyond its normal operating level, and precisely what the failure modes look like before millions of real customers arrive.
That load test provides the raw data you need for the capacity plan.
It defines the real-world operational limits. But preparedness doesn't stop with just knowing your limits. It's a dual requirement that runs in parallel.
What are the two tracks?
It involves two crucial parallel tracks. First, you have to ensure that relevant system metrics are being captured with cloud monitoring and that appropriate, actionable alerts are created at safe threshold levels. You need that real-time visibility so you know when you're approaching the limits that you defined in the load test.
Okay, so monitoring and alerting. What's the second track?
Second, and this is the step that's often missed by less experienced teams, you must review your increased capacity requirements and plan for the required quota management.
Ah, quota management. Explain why that is such a subtle but critical failure point.
It's the hidden trap of the cloud. You might have the best scaling plan in the world. You might have the budget and the tested code. But if you're a cloud provider, due to regional constraints or just default settings, only allows you to provision, say, 100 new CPU cores on demand,
And your plan needs 500.
and your plan requires 500 new cores to handle the holiday load, your entire capacity plan fails instantly. You literally don't have permission to buy the resources you need when you need them.
So operational foresight means securing the allowance, the quota for the necessary resources before you need them to spin up in an emergency.
You secure the capacity allowance months in advance. It's an administrative detail, but it's absolutely critical for proactive reliability.
Okay, finally, let's close the loop on how this entire system ensures continuous improvement. We identified the root cause of that memory exhaustion incident way back in Section 1. How does SRE guarantee that vulnerability never happens again?
This is the critical feedback mechanism. This is where the learning from the past failure directly strengthens the systems of the future. To prevent future severe incidents triggered by software changes, the type of changes that consumed your error budget, the SRE response is to ensure that test cases that catch errors of this type are run successfully before new software releases.
So the postmortem isn't really complete until a new test case is written, committed to the repository, and integrated into the continuous integration pipeline as a mandatory gate.
It transforms a historical failure into a future protective shield. It institutionalizes the learning. The moment that incident occurred, the organization gained new, expensive knowledge. The only way to pay for that knowledge is by turning it into a mandatory preventative measure.
And it ensures the vulnerability that caused the outage can't be accidentally reintroduced 6 months later by a different engineer making an unrelated change.
It's the final step. It's closing the reliability loop.
This deep dive has shown us that SRE is truly a governance model. It's a philosophy of work defined by these structured rules of engagement. We started with the social contract, the blameless culture, dictating that we seek systemic process failures, not personal blame. And we solidify that learning through mandatory, widely shared postmortems.
Then we moved into the action item economy, which uses that single owner rule to enforce forward-looking accountability for the fixes.
It solves the who brings the salad problem.
It really does. And finally, we explored that powerful economic contract, the error budget, which defines reliability as a finite currency.
That framework forces the organization to strategically calculate the return on investment for stability and allows the SRE team to implement a launch freeze, a financial veto, when the debt of instability gets too high.
The central lesson, reinforced by every source we reviewed, is clear. SRE is not merely a set of tools or an organization chart.
It's so much more.
It reinforces that idea that SRE is 50% engineering and 50% diplomacy. It is as much about setting clear social rules like blamelessness and single ownership and economic boundaries, like the error budget, as it is about writing code, managing configuration, or administering infrastructure.
It's a complete system.
It's a complete system for managing the political and financial friction that's just inherent in high-velocity tech organizations.
That distinction between engineering and diplomacy is just vital. Now, as we wrap up and leave you to mull over these rigorous rules of engagement, let's circle back to the error budget and leave you with one final provocative thought.
Okay, we established that the error budget defines your available bandwidth for risk and for velocity. And the sources show that sometimes applications consistently meet their SLOs with a vast margin. They consistently consume maybe 5% of their available budget, or even less.
So if your service is that reliable and you are consistently never consuming more than 5% of your available budget, the question becomes, are you being too reliable?
And what does that remaining 95% of unused budget imply for the velocity of feature development and business innovation? If you are investing tremendous engineering time and resources into a level of stability that your customer contract doesn't actually demand, are you wasting capital? An unused error budget is often an unspent opportunity for faster feature delivery. And that's a crucial calculation every SRE team has to face. Think about the cost of unused stability.